Hello and thanks for using TickBoom. Here I've had a student send through this question which reads, given the modulus of z is less than a half, show that the modulus of 1 plus I times z cubed plus iz is less than 3/4. So if you're just getting started with complex numbers and getting your head around all the different results that are available to you, this question could be quite tricky, because if you try to do it purely from first principles, just by letting z equal x plus iy and then trying to expand, I think you'd get caught up. You'd kind of hit a wall eventually. To tackle this question, I'll just write what we're trying to show, just so we've got it here. So we're being asked to show that the modulus of 1 plus I z cubed plus iz is less than 3 on 4, given that the modulus of z is less than 1 on 2. Now, as I mentioned, if you're just getting started out with complex numbers, your instinct might be to let z equal x plus iy and then try and see where you get to. But actually, the most helpful first step for this question is to use the result that the modulus of 1 plus I z cubed plus iz, notice that that's the modulus of something plus something else. That's going to be less than the modulus of each of the individual things added up. So 1 plus I z cubed plus the modulus of iz. And the reason we can say that is a result called the triangle inequality, which hopefully you've encountered. If not, go have a look. It's something that once you've seen it proven, you don't need to prove it every time. You can just rely on it as a result. But that now, first of all, gets us an inequality. So it gets us into the zone we want. And these individual moduluses will be easier to deal with. So the next thing we can say is that the modulus of each of these, because they're one thing multiplied by another, we can say it's the modulus of each thing multiplied individually, plus the modulus of I times the modulus of z. So that's just using the result that the modulus of A times B is equal to the modulus of A times the modulus of B. So you'll see this question is getting us to use a lot of different results all together to then ultimately get to our destination. So it's a nice question in that it's forcing you to dig into your whole repertoire of different results. From here, maybe what I'll do, just to simplify this a bit further, is that will be less than the modulus of 1 plus I times, and here we can write the modulus of z cubed is the same as the modulus of z all cubed, plus the modulus of I times the modulus of z. So that's using the result, the modulus of a to the n is equal to the modulus of a to the power of n. To simplify this a bit further, basically we want to get things in terms of z. So this is already in terms of z, this is 2. 1 plus I times the modulus of z cubed plus, now the modulus of I by itself is simply going to be 1 times the modulus of z. So really what that leaves, the last thing to really grapple with is this modulus of 1 plus I. And what I'll do, just separately as a side step, let's just let z, some z, I guess not to confuse it with this z, I'll just call it z1. Let's let that equal to 1 plus I. And what we therefore know is that z1 bar is equal to 1 minus I. And the result we want to rely on that's going to help us is that the modulus of z1 squared is going to be equal to z1 times z1 bar. When you take a complex number and multiply it by its conjugate, that is the modulus of that complex number squared. So what is Z1 times Z1 bar? Z1 times Z1 bar is equal to 1 plus I times 1 minus I, just by the way we defined it. So if we expand that, we'll get 1 minus I plus I minus I squared. These two i's cancel. I squared is negative 1, so it's minus minus 1, so we get 2. Therefore, the modulus of Z1 squared equals 2. So the modulus of Z1 is equal to the square root of 2. So now we can come back to our main result. So therefore, the modulus of 1 plus I Z cubed plus I Z is less than this modulus of 1 plus I, we've just shown to be the square root of 2, times the modulus of Z is less than a half, so this inequality can hold if we now insert the half cubed plus 1 times, and again if we insert our half, the inequality still holds, so plus a half. So that means it's less than root 2 on times 1 on 2 times 2 times 2 is 4 times 2 is 8 plus a half. Now here, because we're dealing with an inequality, as long as we put something bigger here, the inequality will still hold. So if it's less than root 2 on 8, then it's also going to be less than 2 on 8 plus a half, since root 2 is less than 2. If you take the square root of anything, you'll always get a smaller number, which is less than 1 on 4 plus 1 on 2, which is less than, this would be 2 on 4, 2 plus 1 is 3, so 3 on 4 as required. So that's how you tackle that. I think the key to this question is to start off with this triangle inequality to get into the inequality zone. And I think the way you can realize that the triangle inequality will help you is because you're dealing with the sum of two things, the modulus of the sum of two things. Should always point you to the triangle equality. There's a few other results you need to make use of, but once you do, it all becomes quite straightforward. So hopefully that's been helpful, and tick boom.